All right, folks. So, as always, read the question very carefully and take a look at the number of marks. 2 marks, roughly 90 seconds per mark, roughly a 3-minute question, though this is nowhere near a 3-minute question. Okay, so this is part E. In part A, you actually made a calculation of the mass of sodium hydroxide needed to make 500 centimeters cubed to 0.25 molar sodium hydroxide solution. Now, in this one, they're asking you to explain why the sodium hydroxide solution must be standardized. Assume no systematic errors. So, a couple of points here that need to be explained. The first one needs to be explained is actually the word explain. If you look at the chemistry guide on pages 87 and 88, there are command terms. This is what these different verbs mean, okay? The difference between compare and contrast or comment. Explain means give a detailed account, including reasons or causes. So you will never, I don't think, get an explain question that's only going to be 1 mark because you're going to have a cause and then you're going to have an effect. Then you've got the word standardized. That is what was going on when you were reacting it with the hydrochloric acid that you knew the concentration of. This is standardizing the sodium hydroxide so you know exactly what it is. Finally, assume there are no systematic errors. Systematic errors are errors that always go one way. So, for example, if you did not calibrate your balance and your balance started off reading 0.50 grams, then every measurement that you took would be zero point 0.5 grams too high. That's a systematic error. All right, so all of that said, all of those things are important for testing in the IB. Why must the sodium hydroxide solution be standardized? Remember that you had to measure a solid sodium hydroxide to make the solution. The thing is, sodium hydroxide will absorb water out of the air. So sodium hydroxide is hydroscopic. That's actually the word. If you don't remember the word, you can simply say sodium hydroxide will absorb water from the air. So, and you don't actually have to put this bit in there, but it absorbs water out of the air. So if you have, say, I don't know, 1 gram of sodium hydroxide that you measure, then maybe you only have 0.9 grams of sodium hydroxide and you have 0.1 grams of water because the sodium hydroxide absorbs the water out of the air. Now I'm making those numbers up, but that's the general idea. What you put in is actually has less sodium hydroxide than you think it does. Now, that is the cause. What is the effect? The effect is that the measured mass has less sodium hydroxide. We can just leave it like that. The measured mass has less sodium hydroxide, or the actual sodium hydroxide mass is not the measured mass. You can put it in any number of ways. And remember, they're looking for things you get right, not things that you get wrong. Okay? So that probably should be our 2 marks right there. Let's check the mark scheme. Solid sodium hydroxide is hygroscopic, will absorb water or moisture from the air. So yes, there was our first mark right there. It also says that it will react with carbon dioxide, absorbs carbon dioxide from the air. If you've studied the whole syllabus, you know that carbon dioxide is actually an acidic oxide, and you know that sodium hydroxide is a base. And so, of course, sodium hydroxide will react with absorbed carbon dioxide from the air. So then the second mark, actual concentration cannot be determined by mass of sodium hydroxide. Well, I am reasonably confident that you are going to get the mark with what you have, because if the measured mass has less sodium hydroxide, or the actual sodium hydroxide is not the measured mass, then the concentration will also be incorrect. Remember, you don't know exactly what's on the mark scheme. You're just going to have to do your best with what you've got. And if you get 1 out of every 2 questions or marks wrong, congratulations, you're going to get a 4.